Hi, this is Brandon Baines in the Math Department at Lipscomb University. Here to talk with you today about counting the number of arrangements of a collection of objects. In this app, you'll learn how to count the number of arrangements or orderings. We'll also sometimes use the word permutation here. So three words floating around: arrangements, orderings, and permutation. They're all kind of synonymous. These are arrangements of a collection of objects. For example, you might be asked to calculate the number of ways that an 8-team basketball tournament can finish with places 1st through 8th. We'll also learn how to count the number of arrangements, or again, orderings, permutations, so on, of a certain size from a collection of objects. So going back to the basketball tournament example, we still have 8 teams in the basketball tournament, but we might be asking a different question, and that is, how can just the 1st through 3rd place finish? How many ways could that occur? When we use the word permutation, we're talking about an ordered arrangement of a collection of objects. So one word that really sticks out there is the word order. When we're counting these arrangements, if we change the order, and that would make a different outcome, then we're talking about this idea of a permutation. So in the basketball tournament example, we can think about maybe the 1st place being the Lakers. That's my childhood favorite basketball team. 2nd place being the Warriors, and 3rd place being the Cavs. Well, if we switch the order of those, put the Warriors in 1st place, the Lakers in 2nd, and the Cavaliers in 3rd, then that indeed is a different outcome, right? The Lakers are winning the championship versus the Warriors winning the championship, and so on. Okay, so permutations, anytime we use this language, we're talking about things where the order is important. Let's take a look at an example. Suppose we have a club that has 12 members, and they're going to be seated together at a concert. We might be interested in how many different ways they can sit together. The fundamental counting principle will still help us find this solution. In this case, we have 12 seats, so we will consider this to have 12 events in the fundamental counting principle language, 12 events. And the first seat could be occupied by any of the 12 members, but once that seat is filled, then the next seat, there's only 11 choices, and 10 choices for the 3rd seat, and so on. And so the fundamental counting principle would have us do 12 times 11, and so on, all the way down to 1. That results in 479,001,600 ways. It's quite a few. Introduce to you the idea of n factorial. This is notationally, it's n with an exclamation mark, or n is in this case representing any number greater than or equal to 0. Not any number, but any integer greater than or equal to 0. And n factorial is defined to be the product of n times n minus 1 times n minus 2 times n minus 3, all the way down to multiplying by 1. So if we were doing 3 factorial, we would do 3 times 2 times 1. 0 factorial is a special factorial. It doesn't follow this definition. It is just simply defined to have a value of 1. So if in any of our counting problems we do a 0 factorial, we're just going to call it 1, because that's what it's defined to be. N factorial is actually the way of calculating the number of permutations or orderings of n objects. So if we toggle back to our previous example, we were ordering our 12 members in a seating arrangement, and you'll notice we multiplied 12 times 11 all the way down to 1. And that corresponds to the definition of n factorial that we see here on this slide. Some of our calculations will ask us to simplify factorial, so it would be a good idea for us just to practice that now. So we'll take a look at 8 factorial. We'll take a look at the expression 4 factorial divided by 2 factorial. And we'll take a look at the expression n minus 1 factorial divided by n factorial. For 8 factorial, we'll follow the definition of n factorial, and we will do 8 times 7 times 6 and so on all the way down to 1. That results in 40,320. For 4 factorial divided by 2 factorial, we'll first execute the definition of factorial. So 4 times 3 times 2 times 1 is 4 factorial. And instead of writing 2 factorial, I'm going to write the definition here, 2 times 1. From there, we can divide common factors that divide to equal 1. That results in just 4 times 3. And that finally gives us 12. For n minus 1 factorial divided by n factorial, we'll do the same thing. We'll execute the definition of factorial. So n minus 1 factorial would start with n minus 1 and then progressively reduce by 1 until we multiply by 1. And then again divided by n factorial. Similar thing occurs here as in our previous example. In our previous example, we had common factors that we could divide out. We did 2 divided by 2 and 1 divided by 1. In this example here, we actually have common factors of n minus 1 and n minus 1, n minus 2 and n minus 2, and n minus 3, and n minus 3, and so on. All of these are common factors, so the only factor left in the denominator is n, and so this results in 1 over n. Let's take a look at a third example. We have the same club that has 12 members. They're going to elect a president, vice president, secretary, and treasurer. We're interested in knowing how many ways the club can elect these officers. Again, we'll continue to use the fundamental accounting principle here, and we'll consider there are 4 events: the event of selecting a president, the event of selecting a vice president, a secretary, and a treasurer. For the president, there are 12 options. Now, generally, and we should be very upfront about our assumptions, we're going to assume that the president's not going to be the vice president. So when we go to consider how many selections we have for our vice president, we are reducing that to 11 instead of 12 because somebody's been elected the president. When we go to think about how many ways we could elect a secretary, again, we would call it 10 ways because, again, in the way we're counting these, we've already considered the selection of a president and vice president. So there are 10 ways. And then to select a treasurer, there would be nine people left to select as treasurer. That product results in 11,880 ways. Introduce to you the notation and the definition of NPR. Okay, NPR, you'll notice the N and the R are subscripts here. And the definition here is n factorial divided by n minus r factorial. But this corresponds to the number of orderings or permutations of n objects taken r at a time. If we think back to our previous example, we would say we had 12 members, and we were gonna make orderings of those 12 members, 4 members at a time. That was our president, vice president, secretary, and treasurer. Okay, so our ordering contained only 4 members. Executing the definition of NPR, we end up with 12 factorial over 12 minus 4 factorial. And cleaning that up and so on, you'll notice that we end up doing this exact same calculation as we did when we just used the fundamental accounting principle. Let's take a look at one final example. We have 8 teams in a basketball tournament.